I'm William Wrangham, and this is Horizons. The world's ice is melting faster than previously thought, and it's threatening our planet with potentially massive sea level rise, weather disruptions, and further global warming. Next up, why researchers are studying the so-called Doomsday Glacier and what it tells us about the fate of ice on Earth.
Support for Horizons has been provided by Steve and Marilyn Kerman. Additional support is provided by Friends of the NewsHour. This program was made possible by contributions to your PBS station from viewers like you. Thank you. From the David M. Rubenstein studio at WETA in Washington, here is William Wrangham.
Welcome to Horizons. As we continue to warm the planet, we keep breaking temperature records. The past decade was the hottest decade in recorded history. We've also seen the cascading disasters that are made worse with each fraction of a degree of warming. Fires in California, floods across India and Southeast Asia, devastating hurricanes in the Caribbean. What we don't pay nearly as much attention to is what climate change is doing to the colossal amounts of ice on the top and bottom of the world. The ice up in the Arctic and down on Antarctica play some critical roles in maintaining life on Earth. That ice helps steer our planet's ocean currents, which are major drivers of our weather. They're the biggest reservoirs of fresh water on Earth. But if enough of that ice melts, sea levels could rise all over the world. So we're going to look at today at the fate of ice on Earth, and we're going to start in Antarctica. Our colleague, PBS NewsHour science correspondent Miles O'Brien, is just off the west coast of Antarctica, and he joins us now. Miles, so nice to see you at such a distance. For those who didn't see your terrific report on the NewsHour this week, explain to us, where are you right now, and why are you there?
William, I'm very near the Thwaites Glacier, which is probably the most consequential piece of ice on the planet. I'm on a Korean icebreaker, which has on the order of 40 scientists from all over the world, and they're here to study this glacier every which way they can think of. They're going to fly aircraft over it using deep penetrating radar to characterize the ice and the terrain below. They're going to measure the water all around it, going downstream of it. They are going to look at the sea ice. And at the marquee level, they are going to be drilling a small hole at the place they call the grounding line. This is where the glacier, the Amundsen Sea, and the land all meet. And that's the point where the warm water is meeting the ice. And that's why this glacier, Thwaites, is melting faster than any glacier we know of on Earth. And that's why I call it consequential.
Before we delve more into that work, can you just, you are sitting in a place that very, very few humans have ever been or will ever get a chance to go. And I just wonder, from your own perspective, what was that like getting there and seeing this place for the first time?
Well, the journey itself is a story to tell. You know, going on an icebreaker through the Southern Ocean is an experience. And watching the captain figure out a way through the cracks in the ice, they call them leads, 2 solid days of going back and forth and around to get through it. That in and of itself was fascinating. But then when we broke through the ice, well, we all went to sleep except for the captain. I woke up on the morning of January 8th, walked outside, and was presented with the face of the glacier, the Thwaites Glacier, staring me right in the face. One thing you don't fully appreciate is the enormity, the scale. This is a glacier that has the footprint of Florida. But the other thing that I wasn't expecting was just the sheer beauty of it. And it really took me back. I was looking at it and marveling at what I was seeing and the beautiful planet we live on. And I was soon brought to tears by it. And part of that is the bittersweet idea that this beautiful thing that we traveled so long and hard over a couple of weeks to get to, as beautiful as it is, humans seem determined to melt it away. And that created, for me, a very powerful emotional moment.
I can only imagine. Can you talk a little bit about, I mean, Thwaites itself, when you describe it as the size of Florida, excuse me, but it's just one tiny part of that enormous continent behind you. It's hard to really explain the scale of a continent covered almost completely in ice. But can you give us a shot at that? Help us understand what is behind you there.
All right, so the Antarctic landmass itself is about the size of the US plus Mexico. So there's your size reference right there. It is covered in ice almost completely. Much of the ice sometimes is miles thick. It has on it about 90% of the world's ice. Think of that. 90% of the ice in the world is right near where I am sitting right now on this vessel. That ice contains roughly upwards of 70% of the fresh water in the world. So for context, if all of this ice melted in Antarctica, we're not saying that's happening right now, of course, but that would represent close to 200 feet of sea level rise all over the world. So the idea that these glaciers are far away and not important to us in our daily lives is something we probably should put out of our mind, and we should be thinking about how important they are.
So you and the researchers have taken this arduous trip to get there. They are now taking these helicopter trips from the ship you're sitting on out onto the glacier. I take it that has been a challenge in and of itself.
Yes, we were hampered by bad weather for quite a while, and it's eaten away at all of their margin. And when I say bad weather, it was kind of calm and warm, but that created a lot of low clouds in the area where this camp is on the so-called grounding line. And you have to remember, this is a featureless expanse of white ice meeting cloud. And what that creates is a whiteout condition for the pilots. It's very dangerous, can create what we call spatial disorientation. But the weather has lifted. As you can see, it's a bright sunny day now. The helicopters have put that camp in over the past couple of days. We had a chance to go see the camp yesterday briefly by helicopter, about a 10-minute ride from where we are right now. They brought in upwards of 30 sling loads of equipment, and they're now very busy at that camp with no margin now, setting up this camp to drill a hot water hole, poke a tiny hole in that glacier, and send instruments down to the Amundsen Sea beneath.
You mentioned before that Thwaites, this glacier itself, is the most consequential glacier on Earth. Some people have dubbed this the Doomsday Glacier. I know a lot of researchers sort of hate that term, but the consequential nature of it is because it is melting so fast. Is that right?
Yes, as far as the doomsday part, I think researchers recoil at it because it sort of sounds like a comic book villain. And let's remember, the glacier is not the villain. Human beings are the villain that are making the ice melt.
Right.
Now, that's an important point. Now, Thwaites itself contains enough, if melted, enough water to raise sea level the world over 2.5 feet. That's just one glacier. And it is buttressing two other ice shelves, which would add another 10 feet. So that if it starts this cascade of melt and collapse, there would be very little to stop it from causing about 10 feet of sea level rise all over the world. Thwaites sits on a precipice. It is grounded on turf that is land that is below sea level. And so as the warm water from the Amundsen Sea gets underneath it and starts eating away at it, and it makes its way downhill toward the South Pole, there's really nothing to stop that melt. And so scientists would like to get some unprecedented data as to exactly how warm it is on there, what the ocean currents are, and what the terrain is underneath. Is there anything to stop it from that cascading melt?
And what is the mechanism of that melting? Is it as crude as some people might think, that we have warmed the atmosphere, ergo the ice is melting?
Yeah, this is a little bit of the knee bone connected to the thigh bone stuff, but basically you have to go to the tropics and look at how the warm temperatures due to climate change have changed wind patterns. Those wind patterns connect all the way down here and have changed the way wind flows around the Antarctic. That in turn has allowed the fresh cold water, which melts off the glaciers, a freer route to the sea, opening a pathway for the warmer ocean currents beneath to make their way to Thwaites. And Thwaites uniquely has this warm water lapping up against it. And that's why scientists are so interested in it. So you have this big glacier, it sits below sea level, and it has this unfortunate coincidence that warm water, warm ocean currents are making their way right to that so-called grounding line. It's kind of a perfect storm.
You mentioned that Thwaites itself and the fate of Thwaites matters just because that's an enormous amount of ice, but it also serves as a buttress. Like, what is it doing to those other ice shelves?
Well, think of it as a keystone. And, scientists are pretty concerned that as Thwaites disappears, you're pulling the keystone out or you're pulling the cork out of the champagne bottle, and the Ross and Ronnie ice shelves would come along with it. There really is nothing holding them back except for Thwaites. And again, there's this, cascade effect because of the nature of the terrain in Antarctica. So all of this is, with limited data, we have to point out that the fact that they are here, and this is an unprecedented attempt to get temperatures, current, salinity at the place where the melting is occurring, shows you how little data this is. Up to this point, William, as you well know, most of what they know about Thwaites is from space, from satellite imagery. There's been precious little data on the ground and in the water, and it's not like there are weather stations here, obviously.
Miles, it's hard not to note that you are sitting on a Korean research vessel. Is there something to be read into that, in that that is not a U.S. research vessel, and this seems that the current administration does not seem as interested in the science that's being done right behind you?
Yes, the U.S., long the leader in Antarctic research, no longer has an operative research icebreaker. The National Science Foundation, which operates the Antarctic program, had to end its lease of the Nathaniel B. Palmer, its research icebreaker, because of budget cuts. The Trump administration cut the National Science Foundation by about 55%, the Antarctic program by about 70%. And meanwhile, the Koreans are going full steam ahead in the opposite direction. This vessel is a highly capable vessel, has 2 helicopters on board, is doing things no other icebreaker in the world can or is attempting to do. And they're building a new one, twice as large. And they are funded for their polar research firm until 2031. So Korea has stepped in and taken a leadership role in Antarctic research. And I think the world owes them a debt of gratitude for doing this, because the U.S. has retreated.
And Miles, last question. You mentioned that there's an expiration date that you guys have to get out of there at a certain point. So is this research going to be done in time to answer the questions they want to answer?
We're right on the edge, but the camp is being built right now. I was talking to the leaders of the camp yesterday, the British Antarctic Survey, and they said they will be drilling in 1 week, which is their kind of the drop dead deadline to get done and out of there on time. And they believe they can pull it off. They've never done it this quickly, however. So this is unprecedented. They have a lot of help out there, and they think they can pull it off. The vessel has to go back toward New Zealand starting around February 10th, because it has one more leg to Antarctica to perform to replenish one of their research facilities on the Antarctic mainland. So we have a firm deadline here. The scientists are aware of it, but there's nothing like a deadline, as you know, William, to focus the mind.
That is right. Miles O'Brien, always great to talk to you. Thank you so much, and safe journey back home.
Pleasure, William.
We're going to pivot now to the other end of our planet, to the Arctic. The Arctic Circle holds the second largest source of ice on Earth, mainly on the ice sheet that sits atop Greenland. But its vast amount of floating sea ice is also a critical part of the Arctic system. And so we are now joined by glaciologist Erin Pettit. She teaches geophysics and glaciology at Oregon State University. She leads a team studying the Thwaites Glacier, has led 2 expeditions there, and has also done extensive work in the Arctic. Aaron Pettit, thank you so much for being here. We just heard from Miles on Thwaites, where you have done a considerable amount of work and continue to do so. You're heading up to the Arctic this summer. Could you just give us, broadly speaking, a sense of what is the trend line with regards to ice in the Arctic?
Yeah, thanks for having me. And it just brought back so many memories of seeing what's going on down at Thwaites. And I just cheer on the collaborators that are working down there. A lot of good people doing good work down there, and I feel like they're going to be able to accomplish that goal that they've set for themselves to drill by next week. So, um, yeah, the Arctic is also consequential, but in slightly different ways. So the Greenland ice sheet has like Miles said, 90% of the ice is in Antarctica, but that other 10% is mostly in Greenland. That ice is currently uh, contributing something like 20% of our sea level rise, more than what Antarctica is contributing right now. But those balances might change in the future. But right now, Greenland is something that we care deeply about in terms of sea level rise and a variety of other processes up in the Arctic. Sea ice, which is the very thin layer of frozen ocean that covers the whole Arctic Ocean in the middle. It expands and shrinks and thickens and thins through time, but it never gets much more than a few feet, maybe up to 10 feet thick. That is also an incredibly consequential piece of ice that has been shrinking rapidly. Last year we had it normally will expand in the winter and then shrink in the summer. This last winter, it did not grow any bigger than it's ever grown before. So was the smallest extent of that sea ice.
Help us understand why we should care about the sea ice, because it's already in the water. It's not contributing to sea level rise. We know, as you're saying, it does wax and wane naturally. So why is that it's shrinking a concern?
Sure. Yeah. So the sea ice plays a super critical role, actually, several super critical roles in our overall climate system that are a little bit separate from the question of sea level rise. First of all, that Arctic ice sheet is actually reflects sunlight back into space. And so it helps control the warmth of our atmosphere just by purely reflecting that sun back into space. So as we limit that area, we will lose that reflective ability. But the other piece that we often kind of forget about, but is super important, is that the atmosphere and the oceans are constantly interacting with each other. And Miles touched on this as well with the winds, the way the winds affect the ocean down at Thwaites Glacier. But everywhere on Earth, the atmosphere and the ocean are exchanging energy and heat, and that's what the winds and the waves and all of that action on the ocean surface that we see is that connection between the atmosphere and the ocean. In the Arctic, you have this thin layer of ice that separates those two. And so the connection between the atmosphere and the ocean is very different in the Arctic when the ice is there. If you take that ice away, suddenly you're going to have totally different types of storms. You're going to generate ocean circulations or modify where they go. You're causing erosions of the landscape along the coastlines. That having that boundary between the atmosphere and the ocean up in the Arctic will helps modulate the entire northern hemisphere weather. And so if we get rid of it, we will suddenly have different patterns of the storms and the winds and the ocean currents all over the Arctic, which sometimes feeds down into where we are.
It's really amazing how such a thin layer of ice can have such a big impact. I also want to ask about the Greenland ice sheet. When we were talking before, you mentioned that years ago, the ice sheet atop Greenland was considered kind of the quiet, boring, uninteresting ice sheet. Doesn't sound like it's that way anymore.
Yeah, absolutely. So that what Miles was talking about, how the Thwaites Glacier is sitting deep on the ocean bottom. So there's a lot of ice can float and be really dynamic as it retreats. Greenland sits on the continent. It sits on a big, vast shield of rock, and so therefore, back in the 90s or earlier, it didn't seem like it could respond as quickly as the Antarctic ice sheet. But sometime in the early 2000s, we were able to see from satellites that indeed it does have the ability to change really quickly. And right now, as I said, Greenland is contributing something like 20% of our sea level rise. Half of that is coming from just melt on the surface of the ice. So this is where just the warmth of the atmosphere is just melting the surface of the entire Greenland ice sheet in ways that it had never done before. The other 50% of that comes from activity in these tidewater glaciers, which are bigger and massive tidewater glaciers than we have in Alaska, but they behave somewhat similarly to Alaska. So it's a little bit different dynamics from the scientific point of view, but there's a lot of similarities. And so this summer, I will be going with the British Antarctic Survey to Southeast Greenland. And one of our questions there is how these tidewater glaciers behave. So how they calve and break and melt into the ocean at the terminus.
We heard Miles talking about how he hopes that people who are miles and miles away from these glaciers appreciate the connectivity of what is happening on the poles of our planet to their own daily lives. And I wonder how you think about that and how you talk about that. I know you're not a doomsday type person, but how do you take the research that you know, the gravity of the circumstance we are in, and how do you communicate that to the public when you're talking about this?
Yeah, so for me, like Miles as well talked about the beauty of these landscapes. They are just these fascinating landscapes. The ice itself is this presence on a landscape that has evolved and changed and affected humans forever, even though it seems like it's far away. And so I always like come back to that beauty and just the massive presence on the landscapes that really kind of helps ground me in kind of who I am as a human. Um, and yeah, I do want to be on the more hope side than the more doom side, but I also feel like we can't pretend that this ice isn't happening. We see it in our satellites, like the GRACE satellite that NASA has is an amazing satellite that essentially has put Greenland on a scale, and you can watch the weight of Greenland go down and down and down as it loses this mass. Where that tells us overall how much Greenland is moving and how much Greenland is losing. And most of that, because it's in the northern hemisphere where so many of us live, it is going to impact the weather systems within the northern hemisphere, and especially in the North Atlantic, where the fresh water that comes off Greenland flows out. And because fresh water floats, it goes over the North Atlantic. And just like I talked about with the ice in the Arctic, that fresh water forms a different kind of a barrier between the atmosphere and the ocean, and is going to be changing the circulation across the North Atlantic, which will impact the weather systems, especially all across Europe and East, because weather systems tend to go from west to east.
It really is striking how much interconnectivity there is. Again, people have a very hard time putting these things into perspective. Erin Pettit at Oregon State University, really, really appreciate your time. Thank you so much for talking with us.
Yeah, this was fun. Thanks.
Before we go, we want to leave you with something a bit hopeful. We will be covering climate change a lot on Horizons, but it is not all bad news, especially when it comes to renewable energy, perhaps our best way to address climate change. I want you to look at this chart. This shows the different ways the U.S. makes electricity. This is March of last year, and that top black line is the burning of things like coal and gas. The bottom green line is renewable sources. And right there at the very end, it shows that the U.S. generated more electricity with renewables than with fossil fuels. This is a major shift, and we will be seeing more periods like this. Same thing happened in Europe last summer. Solar energy, that line in green, was the biggest source of electricity for the entire European Union last June. It's the first time that's ever happened. Same trends are happening elsewhere. In China, which is the world's largest polluter, they are generating huge amounts of power using solar and wind. In fact, because of renewable energy, China's carbon emissions are now, according to one analysis, flattening or even going down. even as China builds new coal plants. This does not mean that the era of oil and coal and gas is over. We will be using fossil fuels for a long time to come. But nations all over the world are quickly learning that pointing a sheet of glass at the sun or sticking a windmill up into the air is proving to be economically and environmentally the smartest move. That is it for this episode of Horizons. You can find us on YouTube and wherever you get your podcasts. See you next week.
Support for Horizons has been provided by Steve and Marilyn Kerman. Additional support is provided by Friends of the NewsHour. This program was made possible by contributions to your PBS station from viewers like you. Thank you.
You're watching PBS.